Here's our other display diff, so I can show you now how the oil works. This is the back end of the diff. This is showing our peg system, but if I take the crown wheel out, behind the crown wheel up here, that's the lubrication holes. So the crown wheel rotates and it pushes the oil up here and it pops out at the other end, which I'll show you in a minute. So really it's a fairly hopeless system, because you're dribbling a little bit of oil up a whopping great hole where the diff nose is facing upwards on the back and trying to drain back down. So the oil vane is going to catch that at the other end and flick it around. I'll show you the other end. If I show you on our cutaway demonstration diff, this is the area we're putting the oil vane on the top here of the bearing. This is going to be squeezed by the dry flange. There's the oil hole. This is where the oil eventually comes out of. It's just a whopping great hole. It tries to dribble out, and because it will dribble back down again, because the diff in the rear, the pinion here with the prop shaft attached, the vehicle's going forwards and the diff is pointing upwards, so the oil is really pushing into the back rather than the front. So we've really got to make use of whatever is coming out of here, catching it with the oil vane and flicking it around the bearing. Now bear in mind, this is a heavy duty crown wheel, so as this rotates in the rear, it's actually scooping the oil up into here and flicking it at the oil. But on a front diff, this runs in the opposite direction, so it's actually trying to push oil up a hole with a curved surface the wrong way. So that's really inefficient. Now the front diff, although you say, well, you're going forward so the oil is being pushed to the front of the diff, that diff's pointing up in the air as well. So not a great combination for oiling either, because now you've got the reverse. Now if we put a reverse cut gear where these are all cut in the opposite direction, then the oil is going to be scooping up better than a standard crown wheel. But we've made these front and rear scoop anyway, so even with a standard gear rotating the wrong direction, it's still going to be a massive increase in oil lubrication. So here is our new oil vane. A lot of people might wonder why we've got a hexagonal in the middle. That doesn't really matter in terms of clamping. It was done so that we could actually have the tooling made to turn the vanes with the little angles on here. The little hole that you see in the middle there by my thumb, that is smack bang over the center of the roller. There's only 2.8 millimeters here to actually get oil in, so that is a central hole. Then these slots here, that actually sits just on the roller itself, and then it will obviously go down the center hole as well. Now what you've got here is one version, and what you've got here is the other version, because as a lot of people don't realize, the front diff runs in the opposite direction to the rear diff. As you saw in the oil system, it's really almost like a centrifugal oiling system, which doesn't work very well. So this is going to spin the oil around and fill the cavity between the pinion seal, which is going to be here underneath the dry flange with the super seal, and chuck the oil all the way around here. The one downside of this is if your pinion seal is leaking, it's going to leak even more, because it's going to keep the oil up here and move it around. But pinion tail bearings are the #1 failure point after the actual silly dust shield, which we've developed the super flange for. I'll show you how this goes together. This vane, whether it's a front or a rear, sits on top of there. The seal goes into the housing around here, and then you've got the dry flange, which will drop down on the splines like that, trapping that and bolting it together with the bolt at the top with the big washer, and that then is going to help to keep this bearing oiled. Very simple idea, but I think it will pay dividends. So we've got fronts and we've got rears, and I think this is going to be a great addition to our making differentials more reliable and stronger. It really did take some designing and calculations to get this dead right. This vane here is literally right to the edge of the cage, so it absolutely fills the bearing area. We've got the little holes here for dripping through, we've got the big slots here for it dropping through, but this is all smack bang in line with the bearing. So now we'll actually build our first unit with one of these vanes in. Okay, the first stage is to do what we normally do, which is to build the pinion into the casing. So there's a head bearing in there, there's a tail bearing in there, we've got our super flange on our build flange on the end. What we do now is, this is all set up and correct with 8 foot-pound, I think it was, on the pinion preload. We're now going to remove this and fit the oil vane. So with the pinion flange removed, we're looking at the end of the pinion, and we've got the tail bearing looking out at us. And what we're going to do now is we're going to put the oil vane in and then the oil seal with a modified super flange, because we've got to take up some extra room. So there's the oil vane all fitted in place, and now we're going to put the seal in and the dry flange for it. So seal in place, special tool we have to put the seal in so we don't damage it. Seals fitted in position for the super flange, which is different to where they normally sit as standard. So that's now in with the oil vane behind. And then the modified dry flange goes in through the seal with a bit of oil on, into position, and then the bolt is put on the end and torqued up. And then again we'll have our upgraded 10.9 grade flange head bolts and some sealer to stop any capillary action. There is the super flange Mark II for the oil vane fitted, all ready now to finish the build. This is having a whole lot thrown at it: high flow washers, tab lock system, an ash locker, and a new heavy duty cram wheel and pinion. Should be a lovely build. And with the dry flange on, you can now see that trapped in the middle there is the oil vane that's going to rotate and flick the oil about over the bearing surface.